I'm going to talk a little bit about angle measures of polygons. Again, a lot of these are probably formulas that you've seen before, but I also want you to know where the basic formula comes from. It's pretty easy to get the formula slightly wrong, and then you end up making lots of mistakes. So some basic things here. First of all, you can derive the formula for the interior angle sum of a polygon just by drawing some different polygons and breaking them up into triangles. The pattern is relatively simple. So I'm going to try just a couple of shapes here. All right, so if I take any quadrilateral and I pick one vertex, I can split that shape up into triangles, okay? And the angles of the triangles completely form the angles of the polygon. So we basically have four sides here. The shape breaks up into four sides, breaks up into two triangles. 2 times 180 tells me that this has 360 total degrees in the interior angle sum, okay? Here's a pentagon, okay? If I pick one vertex and I break this pentagon up into triangles, you can see it has 5 sides, breaks up into 3 triangles, okay? So I can take 3 times 180 degrees for each of these triangles. Notice that the angles of the triangles are completely making up the angles of the pentagon. 3 times 180 is 540 degrees, okay? That is the angle sum for a pentagon. For a hexagon, I can take one vertex and I can draw diagonals to break this up into triangles, okay? 6 sides breaks up into 4 triangles, okay? 4 times 180 degrees is equal to 720 degrees, okay? So if you try this a couple of times, hopefully you're starting to pick up on the pattern. 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. There are always 2 fewer triangles than the number of sides. Each of those triangles has 180 degrees. So that leads me to the interior angle formula, interior angle sum formula. It's just the number of sides minus 2 times 180 degrees. Okay? Now the follow-up to that, I can also find the measures of the individual angles of the shapes. So for example, we saw that a pentagon has a 540 degree angle sum. If it's a regular pentagon, that means all the angle measures would be the same. You can divide 540 by 5, and you find out that you have individual angles that are 108 degrees. Okay? A hexagon. We just saw that a hexagon has a 720 degree interior angle sum. 720 degrees divided by 6 angles tells you that the individual angle measures there are 120 degrees. Okay? An octagon. Octagon, you could use the formula here. Number of sides minus 2 times 180. That'll give you 6 times 180. I believe that's 1080 degrees. Okay? And if you divide 1080 by 8, because there are 8 angles, you find out that each of the angles of an octagon measures 135 degrees. Okay? You need to know these angle measures. You need to know that pentagons have 108 degree angles. You need to know hexagons have 120 degree angles. You need to know that octagons have 135 degree angles. Okay? I think that's all pretty basic. And I would know the angle sum for a pentagon and a hexagon and an octagon as well. But again, the formula is important. You may need to be able to find the interior angle sum for other kinds of shapes, decagon or something like that, and the formula is very easy. Number of sides minus 2 times 180 degrees. Okay? A follow-up. The exterior angle sum. Okay? An exterior angle is created by extending a side of a shape. So for example, if I have a pentagon, I can extend, and you're going to only extend the sides out in one direction. So either all to the right or all to the left. You're only going to draw one exterior angle per vertex. But for example, I can extend this side out here. I'm going to extend out to the right. So I'm going to extend out in this direction, that direction, that direction, and that direction. Okay? You can try this with different shapes, but an interesting feature of exterior angles, if you watch my marker here, if I rotate through the exterior angles, my marker starts out here, I'm going to rotate through that angle, 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 and notice my marker is back where it began. My marker made a full circle all the way around the outside of the shape, okay? Not a proof, but if you try it with different shapes, you'll kind of see that same idea of moving completely around a circle, which leads us to a very important idea. The exterior angle sum for a polygon is always 360 degrees. And that's fascinating because you don't need to know the number of sides to know that the exterior angles are going to add up to 360 degrees. And as a result, this is a fact that I love. I use this all the time, okay? I use the exterior angle sum even to find the measure of interior angles. And here's why, okay? Imagine that I'm working with the Pentagon, regular Pentagon. All of the angle measures are the same. All of the 5 exterior angles are also going to have the same measure. Okay? So if I wanted to find the measure of one of the exterior angles, I can divide 360 by 5. Okay? Turns out to be 72 degrees. All right? But exterior angles are supplementary to interior angles. So I can just subtract 72 from 180, and that tells me that my interior angles are 108 degrees. Okay? That's wonderful, especially if you forget the angle sum formula, or if you're trying to do it in your head. So many different numbers divide into 360 that this can be really simple. Okay, so for example, a hexagon. Okay, if I draw my exterior angles here for a hexagon, the exterior angles, all 6 of them, if I draw them, are going to add up to 360 degrees. So I can divide by 6, telling me that each of my exterior angles is 60. Okay, there's a linear pair of angles. We've got a straight angle here. Subtract 60 from 180 tells you that your interior angles are 120. Okay, really, really useful. Okay. And here's another thing that can be very, very helpful. If you know the measures of the interior angles, but you don't know how many sides the shape has, you're not going to be able to find the angle sum to set it equal to the formula, because you won't know how many sides there are to be able to find that sum. Okay? So let's say that I have some kind of polygon and it's regular. Okay, I should note that. All the angle measures are the same. And let's say that it's got 140 degree angle, and I want to know how many sides it has. Okay? Well, I don't know what it looks like exactly, so I'm just going to kind of draw like part of a shape here. Okay? And I'm going to label my 140. And here's the key. You don't know how many angles there are, so you can't find the angle sum, which means this formula is out. Okay? But you can find the interior angle, and you can use that to find the exterior angle. 140 subtracted from 180 is going to leave you with a 40 out here. All of my exterior angles are going to be 40s, okay? So I just have to figure out how many 40s does it take to add up to that guaranteed exterior angle sum of 360, and I know the number of sides. So 360 divided by 40 is equal to 9. The shape has 9 sides. That means it is a Pentagon, okay? So hopefully that helps. We're going to need angle measures when we're working with different kinds of shapes. Remember, trig relies on angle measures. So if you don't have angle measures of things, especially of shapes, it's going to be hard to apply trig. So really, really important. You need to know both of those formulas. You need to know those formulas all the time. Really super